Next section is conservation of energy. This is number 1. A large chunk of ice with a mass of 15 kilograms falls from a roof 8 meters high above the ground. What is the kinetic energy of the ice as it reaches the ground? So that's going to be the final kinetic energy. What is the speed as it reaches the ground? That's going to be the final speed. Alright? Well, the first thing we probably need to do is calculate up at the top, what is the potential energy? So if this thing is going to fall 8 meters, if I know the potential energy up at the top, the initial potential energy, that is going to equal the final kinetic energy. So the initial potential energy is mass times gravity times height. So it's 15 times 9.8 times 8. So my initial potential energy is 1176 joules. So for part A, what is the final kinetic energy? It's going to be the same, 1176 joules, since it hits the ground. What is its speed as it reaches the ground? Well, kinetic energy is 1/2 mv squared. There's my kinetic energy. I've already figured that out. And I know that my mass is 15 kilograms. So I'm going to multiply by 2, divide by 15. And then I'm going to take the square root, and I'm going to end up with velocity of 12.5 meters per second. I went really quick on that, but you should be able to get that answer. And if you don't, work through it again. Make sure that you do all your algebra correctly, and then you're going to take the square root. Number 2, an 8 kilogram flower pot falls from a window ledge 12 meters above the sidewalk. What is the kinetic energy as it reaches the sidewalk? So that's the final kinetic energy. Using energy considerations only, determine the speed just before it strikes. So that's the final. This problem looks eerily similar. Okay, so the same thing, the potential energy at the top is going to be mgh. The mass is 8 kilograms, gravity is 9.8, and the height is 12. So my initial potential energy is 940.8. Remember, whatever the potential energy at the top is, as long as it hit the ground, that's going to be the final kinetic energy. So final kinetic energy is 1/2 mv squared. So 940.8 equals 1/2 times 8 times v squared. We're going to multiply both sides by 2, divide by 8, and then take the square root. So my final velocity is going to be 15.3 meters per second. Alright, here's number 3. A 15 kilogram model plane flies horizontally at 12.5 meters per second. Calculate the kinetic energy. B says the plane goes into a dive and levels off 20.4 meters closer to the Earth. So let's just do this. Distance is 20.4 meters closer to the Earth. How much did the potential energy lose in the dive? So we want to know the change in potential energy. How much kinetic energy did the plane gain during the dive? So we want to know the change in kinetic energy. And then D says, what is the new kinetic energy? E says, neglecting frictional effects, what is the new horizontal velocity? Alright, well, kinetic energy. Kinetic energy is 1/2 mv squared. So we're going to have 1/2 times 15 times 12.5 squared. So our kinetic energy is going to be 1172. That's the answer to A. B wants us to find the potential energy that it lost in the dive. Alright, well, the change in potential energy is going to be the final potential energy minus the initial potential energy. The other thing that I can think about is, well, if I know the mass and I know the distance that it changed, what I'm going to say is potential energy is mgh, the mass is 15 kilograms, 9.8, and since the change in height was 20.4, this is going to give me the change in my potential energy. So my change in potential energy was almost 3,000 joules. C says, how much kinetic energy did the plane gain during the dive? Well, if you lose potential energy, you're going to gain it in kinetic energy. So it's going to be the same answer right here. That's going to be for B, and it's going to be for C. What is the new kinetic energy? Well, if the initial kinetic energy was 1172 and it gained 2,999, let's just add them together. $41.71. E, neglecting frictional effects, what is the new horizontal velocity? Well, we're going to use the kinetic energy. The kinetic energy is 41.71. The mass is 15 kilograms. Then I've got v squared. Multiply by 2, divide by 15, take the square root, and our new velocity is going to be 23.6.